This example continues on from the previous example. When doing the division, x to the 4 minus 3x cubed plus 4x squared minus 2x plus 3 by x minus 4, we found that we had a quotient, which we can see here, and a remainder of 123. If we look at a number example, suppose we divide 11 by 4. 4 goes into 11 twice, so we get a quotient of 2, and this leaves a remainder of 3. We know that we can write 11 as equal to 4 times 2 plus 3. We can make an equivalent statement for our algebraic division. So when we have x to the 4 minus 3x cubed plus 4x squared minus 2x plus 3, we can write this as equal to the x minus 4, which was the divider, multiplied by the quotient add the remainder. And if we compare the expression 11 equals 4 times 2 plus 3, and this expression, x minus 4 times x cubed plus x squared plus 8x plus 30, add 123, we can see the divisor, the quotient, and the remainder are all in the same place. Let's highlight this. Here's our 11, and here's the original polynomial that we divided. We divided 11 by 4, and here it is, and the polynomial by x minus 4, and here it is, in the equivalent position. When we divided 11 by 4, we got a quotient of 2. Here we got a quotient of x cubed plus x squared plus 8x plus 30, and we can see that these are in equivalent positions in our two expressions. The remainders were 3 and 123, and we can see that these are in equivalent positions. So when we divide a polynomial, that polynomial is equal to the divisor multiplied by the quotient, add the remainder. And this will be very important in our last example. The next example is dividing a polynomial by an expression which is not linear. And then we come back and look at this, that a polynomial is equal to the divisor times the quotient plus the remainder in that context. So it's important to remember this example.